Hi guys, welcome back to the channel. I hope you all are doing good. So in this video, we should solve a problem which is called the longest valid parenthesis. And on GFG, it is known as valid substring. So everything will be in the description, all the links, you can check it out. Let us read the problem. I encourage you to pause the video and try the problem. So the problem is, given a string which contains opening and closing brackets, we have to find length of the longest valid well-formed parenthesis. So what does it mean by longest, or let us say what is the meaning of valid parenthesis? See, if opening brackets are equal to closing brackets, then it is known as valid parenthesis. For example, this one, the length of this is 2 and it is a valid parenthesis. Even this one, the length of this is 4 and it is a valid parenthesis. Actually, even this is considered valid and it is length and its length is 8. So any substring which has equal number of opening closing characters. See, it need not always be like this. So if there are 4 opening characters, they should be 4 consecutive. Yes, if this is the case, this is also correct, but we should not exclude this also. So there is opening, closing, then 3 opening, 3 closing. So what does it mean? Whenever there is opening bracket, how many ever opening brackets are there, those many closings should be there. And then again, if opening brackets are there, those many closing brackets should be there. So that entire substring will become valid, like in this example. So this is also valid, this is also valid. So this is the meaning of valid substring, and we have to find the longest one. So there are 3 approaches that I know. So approach number 1. So in approach number 1, we basically use a 2 stacks method. So what is this 2 stacks method? Basically, we have a character stack and we have an index stack. So in character stack, we push all the opening brackets. In character stack, we push all the opening brackets, and in this index stack, we will push all those index values which are causing a problem. I'll repeat that. We push all the index values which cause a problem in forming a valid substring, which can cause a problem, in forming a valid substring. You will understand this more better when we take an example. So let us take an example only. Let us say this is the substring. Okay, so let us say this is the string, this is the string, and let us perform our algorithm. What is the algorithm? Algorithm first tells make 2 stacks. Okay, so 2 stacks are made. Then just insert -1 in this index stack. Why should we insert -1? I shall tell you later on why we should insert -1. So basically insert this -1 index. Okay, and actually this string, let me write it little bigger so that I can show you with index values. So this is index 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7. So now let us run the algorithm. Let us traverse through the string. We are initially at index 0. What is the character at index 0? It is opening bracket. So when we encounter an opening bracket, simply push it to this stack. So we pushed it to the character stack and push the index of this character in the index stack, because if in the future there is a problem that is created because of this opening bracket, if there is a problem created, then we can find the length of the other substring which is valid with the help of this. See, let us take a small example here. What if the string is this? So over here, length of the valid substring is this, right? And if you look carefully, in this example, this substring has no contribution. There is no contribution of this character. This character has no contribution because the longest substring is this one. Longest valid parenthesis is this one. So in this example, we would need the index of this in order to find out length of the longest substring. How we shall see it further? We shall see further how. So first insert the character in the character stack and also its index. If it is an opening bracket. Okay, so now let us go front. When we go front, we encounter what? We encounter a closing bracket. So when we encounter a closing bracket, what we should do? First, we should check if the stack is empty or not. So the stack is not empty. Which stack? Character stack. If the character stack is empty or not. So, okay, character stack is not empty. Then what do? We just pop out the top element, and from the index stack also pop out the corresponding index. Okay. So now we are here, and now we have to set our length. So our length, we have to set our length to maximum of len comma I minus index stack dot top. So initially our length, which will be the answer of the problem, let that be equal to 0. Okay, let the length be 0. But when we encounter a closing bracket, we popped out the character from the stack, from the character stack, we popped out an element, and also from the index stack. And then we check for maximum length. See over here, what is index dot top? Index stack dot top is -1. That is why we need an index -1. Why do we need an index -1? Because of this reason only. See over here, the length of the string that we have got is equal to 2. So I is equal to 1. 1 minus -1. 1 minus -1, this will give us answer 2. That is why we need to put -1 in the stack. So now let us go forward. When we go forward, we have encountered an opening bracket. So push it into the stack, push the index also. We encountered a opening bracket, push it into the stack, push the index also. Now we encountered a closing bracket. When we encounter a closing bracket, we should pop out the character from the stack, top element gone, and pop out this also from index stack. Now what is stack top in index stack? What is stack top 2? What is index of this closing character? 4. So our length will change to maximum of length, which is 2. So this is 2. So this is 2, okay. And what is I minus index stack dot top? It will be 4 minus 2, which is also 2. So length will remain 2 only. Again we encounter a closing bracket. So we should pop out character from stack, from character stack, and from index stack. Now you see I is equal to 5. So length is 2 and I is equal to 5, and index stack dot top is -1. So 5 minus -1 is equal to 6. So 6 is greater than 2. So the answer will change to 6. Like this, we will get the answer as 6 over here. So I hope you understood why we should insert -1 in the first place only, because if there is a longest valid substring which starts from index 0, we are able to count, we are able to find the length with the help of this small hack. So this is two stacks method, but you can observe that this character stack over here did not have much role to play. We didn't need this character stack. Actually speaking, we don't need it, right? What was the use of this character stack? Just push this element, and pop this element. Why do we need it? Let us see only one stack method. So let us see approach number 2, which is only one stack. So only one stack, we will have this stack, index stack. Okay, index stack we will have, and let us see what to do now. So when we have index stack only, again insert -1, and then what do we have to do? So let us traverse through the string. See, initially we get a opening bracket. When we get opening bracket, in method 1, what were we doing when we got opening bracket? We used to push the character in the character stack as well as the index. So now there is no character stack, but we'll push the index. Index is 0. Let us go to closing bracket now. So next character is closing bracket. Whenever we got closing bracket, what we were doing? We were checking if the stack is empty or not. If the stack is empty, actually I forgot to tell you in method 1 what we were doing when stack is empty. If stack is empty, that means we have to push the index only. That's all. We don't have to do anything. Because consider this example. This example, let us consider simple example. If this is the string given to us, when we encounter this opening bracket, the stack has nothing. The character stack has nothing. That means with this, closing bracket. With this closing bracket, we can't make a valid substring. So this is causing a problem. So I put it into the index stack. That is why if the stack is empty, if the index stack is empty, character stack is empty, we used to put the index only. But now we don't have to do all that. Now what we have to do, we have to check if nothing, we don't have to check if stack is empty or not. If we get a closing bracket, we just pop out one element from here. We pop out an element from here, then we check if the stack is empty or not. If the stack is not empty, then we reset the length like this only. So same code, everything remains the same, except we don't need a character stack anymore. So over here index is 1. So length was 0 initially. 1 minus -1 is equal to 2. So length will become 2 now. And similarly, when we reach index 5, length will become 6 by the same algorithm. So in method 1, the only difference is we don't need a character stack. Whenever we encounter an opening bracket, we just include the index in the stack, and we encounter a closing bracket, we pop out the top element, then we check if the stack is empty or not. If it is not empty, we find out the difference in length. I mean, we compare the length with the new length. So let me show you the code. I think you will understand much better. See, this code is for method 1. That is, I have declared a character stack as well as an index stack. After that, I have pushed -1 into the index. I have kept an answer variable over here. Instead of len, I have made it answer. Okay. I am traversing the string now. Whenever I get an opening character, I am going to push the character in the character stack as well as the index in the index stack. When I encounter a closing character, I check if character stack is not empty and if character stack top is this. Actually, I don't have to check for this one. It is obvious that it is going to be that only. So I don't have to actually check for this. You can omit this, or for your better understanding, let me just keep it whatever. You don't actually need this, okay? So I just pop it out. I pop out character. I pop out the top character as well as top index, and then I find out maximum length. I compare with the original answer and try to find out. If the character size is 0, if the character stack size is 0, that means there is no element in the stack. Just push the index. Push the index, because this index will be, it will cause a problem for the future valid substring. Then return the answer. So this is method number 1. Now let me show you method number 2. There is a problem on LeetCode, longest valid parenthesis. So same problem, but over here you can observe I've used only one stack. So index stack, I have pushed index -1. And if I encounter opening bracket, I just push the element, push the index into the index stack. Be careful, we are not pushing the element, we are pushing the index. If it is not a opening bracket, obviously it is a closing bracket. So we pop out the top index. Then we check if stack size is 0 or not. If it is 0, we push the current index. So this statement is same as this statement here. And this if statement will be same as this only. No other difference. We don't need this extra stack. We don't need this extra stack. So you can pause the video and have a look at the code. I think I've explained well enough only. You might have understood by now. Just take some examples, you will understand much better. Take these examples over here. In LeetCode, there are some examples. So this was approach number 2. Now what is approach number 3? Approach number 3 is very interesting actually. It can be done with O of one space. We don't need stack also. We don't even need a stack. Just keep 2 pointers open, close, or left, right. Okay. So if you get a opening bracket, do left plus plus, otherwise do right plus plus. If left is equal to right, then update your answer as answer is equal to 2 into right, or left plus right, whatever. See, 2 into right will be same as left plus right if left is equal to right, right? So you can do this also. And most important is, if right is greater than left, then make both left and right 0. How it is happening? For example, if this is the string, okay, so if this is the string, so add this opening character, my left will become 1, okay, and let us say right over here. So right is 0. When the closing character comes, right will become 1, left is equal to 1 only. So you can see left is equal to 1, right is equal to 1. So over here you can see we got a valid substring. So answer will become maximum of answer or left plus right. So left plus right is what? 1 plus 1, 2. Now similarly here, right will become 2. So right becomes 2, right is greater than left. So make both left and right 0. Because with this we were never going to get a valid substring. At this moment we are not going to get a valid substring, so make it 0. If right is greater than left, we won't get a valid substring. Like that. So this 2-pointer approach is based on that only. But we have to also do the same thing from reverse order. Why should we do it from reverse order? Because all this time we are considering the prefix. We are considering that prefix is having longest valid substring. But what if suffix has? What if there is a string like this? Then what will you do? Yeah. What if there is a substring like this? See over here, how many closing brackets are there? 1, 2, 3, 4, 5. Over here, it will be 1, 2, 3, 4, 5. So in this string, this this substring, or yeah, maybe this one only. 1, 2, 3, 4, 5. Yeah, this substring is longest valid. But for this, if we apply only this much code, then we won't get the answer. Because in this example, longest valid is suffix. It is starting from behind. So we need to check from behind also. And when we traverse the string from behind, everything is same, except here we are checking right is greater than left. Over here, we should check left is greater than right. So if at all left becomes greater than right, then it is not going to be valid. So for prefix or from front side, right greater than left is checking condition, whether it is valid or not. And from the other side, it is left or greater than right. So I've told you 3 approaches. 2 approaches use stack, 1 approach has no stack, constant space. So these are the 3 approaches. I hope you understood now. You can solve this approach. You take some examples and do it. You can take these examples only available in LeetCode, GFG, you can take it. But I explained the most important conditions you may not consider. Thank you for watching this video. If you liked it, hit the like button. Please share it with all your friends as much as possible. Subscribe to the channel. It will really motivate me. And take care, stay safe, keep learning, keep growing. Stay tuned. Bye.